Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we focus on one essential component of the epistemic firewall. In this part 9, we cover the culminating filter, empirical constraints. This is the process by which a pattern observed in scattered phi sentences earns the status of a rule. The skill you will gain is the disciplined understanding of how a fact becomes a law, not by declaration, but by repeatable survival across variation. You will learn to distinguish a one-time coincidence from a persistent constraint of reality. Our core question is, when does repeated observation earn the right to become a rule? This is the heart of induction, the great puzzle of science. We never see a law. We see instances. We see phi sentences. The leap from "I have seen this many times" to "this is a rule that governs future instances" is the most dangerous leap in all of thinking. It is the source of both genius and superstition. The empirical constraint firewall provides the strict, formal protocol for making this leap safely. It replaces faith in repetition with a test of survival across structured variation. The core concept is empirical constraints are inferred from repeatable survival across variation, not from one fit. A single experiment, no matter how precise, cannot establish a rule. 10 identical experiments are little better. They may just be repeating the same accident. A rule emerges when the proposed constraint holds across many independent windows that vary the conditions. Vary the timescales, the spatial scales, the motion context, the instruments, and the reconstruction pipelines. It is the pattern's persistence through this gauntlet of change that grants it authority. Let me state the audio equation that defines this. We say, a constraint is empirical when it holds across many independent windows. For I from 1 to n, G sub I of phi remains satisfied within uncertainty. In symbols, we write, for I equals 1 to n, G sub I of phi is satisfied within delta. The symbol GI represents the check of the proposed constraint in the ith licensed window. The index I runs over many different windows, not copies of the same window, but windows that differ in their parameters. The satisfaction must hold within the declared uncertainty delta for each window. This is not a single data fit. It is a consistency condition across a varied landscape of access points to phi. Now, why is this necessary? The failure mode it prevents is overgeneralization from narrow sampling, the cardinal sin of bad science and everyday superstition. If you only ever test a drug on young men, you might conclude it works for all humans. If you only observe gravity on Earth, you might conclude it is a force that always points down. If you only measure light in a vacuum, you might not discover its wave nature in material. By demanding survival across variation in omega, K, and V regimes, the empirical constraint firewall forces us to probe the rule in its full scope before we grant it a license. It exposes rules that are actually just local habits of a particular setup. To understand this, consider an analogy from the deep cultural practice of Afghan hospitality, the Melmastia. Imagine a traveler visits one village and is welcomed with extraordinary generosity. He might conclude, Afghans have a rule: treat every stranger as an honored guest. This is a proposed constraint G from one window, one village, one time. But is it an empirical rule? To find out, he must test its survival across variation. He must travel to different provinces, variation in K, spatial regime. He must visit in times of plenty and times of drought, variation in omega, temporal regime. He must arrive as a known friend, a neutral trader, and a stranger from a distant land, variation in V, the motion or relational context. If the generous treatment holds consistently across these varied windows, within the expected uncertainties of human behavior, then the traveler can cautiously infer a real empirical cultural constraint. If it breaks down in certain regions or under certain conditions, then the rule is not universal, it is scoped. It might be a rule in the Pashtun belt during peaceful times. The empirical constraint audit reveals the true shape and boundaries of the rule. Without this audit, the traveler's initial generalization is just a hopeful story. In Holophase, the hospitality is a proposed constraint on phi patterns. The traveler is a scientist. The villages are different licensed windows, WI. The empirical constraint is validated only after the audit across I from 1 to n. Now, what is the formal meaning in Holophase terms? A candidate grammar G is a proposed constraint, like the second time derivative of phi is proportional to its second spatial derivative, a wave equation. To elevate G from a candidate to an empirical constraint, we must test it in windows that vary the triunity parameters. 1. Survival across omega regimes, fast, slow. Does G hold for processes with very high temporal frequency, like atomic transitions, and very low frequency, like continental drift? We test in windows with different delta t and sampling rates. 2. Survival across K regimes, local, global. Does G hold at the scale of nanometers, quantum physics, and at the scale of galaxies, cosmology? We test in windows with different delta x and spatial resolutions. 3. Survival across V regimes, different propagation contexts. Does G hold for systems at rest, in constant motion, and in accelerated frames? We test in windows with different V books, relative motion conditions. The constraint G earns empirical status only if it survives this triunity variation. Its satisfaction, G phi equals 0 within delta, must be demonstrated across this wide portfolio of windows. Let's connect this to energy as tally. Remember, energy is an accounting of omega kV coherence. A real empirical rule stabilizes the tally. That is, when you calculate the energy, or any other derived tally, from the phi sentences in all these varied windows, the accounting is consistent and obeys the rule's predictions, like conservation, without ad hoc adjustments. In contrast, spurious rules make the ledger wobble with context. If you have to keep adding correction factors or new forms of energy every time you change the omega k or v regime to make the books balance, your proposed rule is not empirical. It is a patchwork narrative trying to keep up with reality's complexity. Think of it like the accounting for a trans-regional Afghan trade caravan. A real empirical rule of their business might be profit equals goods sold minus costs of goods and transport. This rule should stabilize the ledger across variations. whether trading in Balkh, north, or Kandahar, south, K variation, in summer or winter, omega variation, using camels or trucks, V variation, in a sense. The ledger based on this rule remains coherent. A spurious non-empirical rule might be profit is always 20%. This will force the ledger to wobble wildly. In the South, you'll have to invent special southern market fees to explain losses. In winter, you'll need cold weather deductions. The ledger becomes a mess of context-dependent fixes. The empirical constraint firewall detects this wobble. It rejects the 20% rule as non-empirical because it does not survive variation. It requires constant, context-specific patching. The operational interpretation is the core of the scientific method. Controlled experimentation and diversified observation. To establish an empirical constraint, you must propose a candidate constraint G, design a series of experiments or observations that probe different omega k-v regimes. For each, obtain licensed phi sentences. Check if g of phi equals 0 holds within uncertainty for each window. Perform a meta-check. Does the rule require new parameters or adjustments to fit the data from different regimes? Or does it hold with the same fundamental form? The firewall role of empirical constraints is to block the epistemic failure of premature canonization. It prevents the scientific community from enshrining a locally successful model as a universal law before it has been stress-tested across the full triunity landscape. It is the final gatekeeper before a rule is allowed to guide prediction and understanding in new, untested domains. Let's state clearly what assumptions are allowed and forbidden. Allowed. You may propose a constraint G based on limited data. You may assign it a candidate license. You are encouraged to actively seek out tests in new omega k-v regimes to strengthen or weaken its case. Forbidden. You may not promote a constraint from candidate to a general law, scoped or provisional license, based on repetition in a single regime. You may not ignore contradictory results from other regimes by dismissing them as outside the theory's domain, unless you have previously and explicitly licensed that domain limitation. You may not hide the wobble in the energy tally or other derived quantities. What happens when the check fails? The license consequence is a downgrade along a maturity ladder. A constraint doesn't simply become true or false. It moves along a spectrum of confidence defined by its survival portfolio. The ladder is candidate, scoped, provisional, not universal yet. We will detail this shortly. Now, we must state the explicit prediction and falsification for empirical constraints. Prediction. A real empirical constraint generalizes to new windows drawn from the same scope. If the constraint has been validated across a range of omega from 1 to 100 Hz, across spatial scales from 1 mm to 1 meter, and for velocities from 0 to 100 meters per second, then the prediction is that for a new window with parameters inside that validated range, say omega equals 50 Hz, scale equals 10 centimeters, v equals 50 meters per second, the constraint will hold. The rule predicts its own continued success within its proven scope. This is the basis for all engineering and applied science. Falsification of the rule's current license. A breakdown in a clearly in-scope window downgrades the rule. It is not instantly denied as false. Rather, its license is relicensed with a narrower scope. The falsifying condition is failure within the previously established domain of validity. For example, if Newtonian mechanics, a scoped rule for low velocities, is found to fail for a mechanical system clearly operating at low speed, low v, and human scale, medium k, That would be a catastrophic falsification requiring retirement. But its failure for particles at near light speed is not a falsification of Newtonian mechanics. It is a boundary discovery. It tells us the rule's license needs a V bound, V much less than C. This nuance is critical. The firewall manages falsification not as a dramatic proof of wrongness, but as a precision adjustment of a license. Most great discoveries are not the overthrow of old rules, but the precise mapping of their license boundaries. Let's illustrate with a historical example and an Afghanistan analogy. The rule, water boils at 100 degrees Celsius, is an empirical constraint, but its survival portfolio quickly shows it is scoped. It fails, falsifies within scope, if you test it in a high-altitude window like Kabul, lower air pressure. The license must be narrowed. Water boils at 100 degrees Celsius at standard atmospheric pressure at sea level. The rule hasn't become useless, it has become more precise. Its domain is now explicitly licensed. For the analogy, consider the empirical rule for growing a certain variety of Afghan melon, Gandana. Farmers in Helmand might have a rule: plant after the last frost, irrigate every 7 days. This rule has a survival portfolio based on Helmand soil and climate, a specific K and omega regime. If a farmer takes this rule to the highlands of Bamyan, a different K regime, different soil, temperature, and applies it, the crop may fail. This is not a falsification of agricultural science. It is a boundary discovery. The rule's license must be amended for silty, low-altitude soil in a warm climate. The Bamyan farmer must now establish a new empirical constraint for his own window. The firewall's job is to ensure the Helmand rule is not exported as a universal truth without testing its survival in the new regime. Now, we must formalize the license maturity ladder, that is the key output of the empirical constraint process. 1. Candidate. A constraint G that fits one or a few similar windows. It has no predictive license outside those specific conditions. It is a hypothesis. Most proposed ideas start and die here. 2. Scoped. A constraint G that has survived testing across a defined range of omega, K, and V parameters. Its license is explicitly limited, valid for mechanical systems with V less than 1% of light speed, scales above 1 micrometer, and timescales above 1 nanosecond. This is a powerful, useful license. Most of engineering operates with scoped rules, like Newton's laws, Ohm's law. 3. Provisional, universal aspirant. A constraint G that has survived all tests across every omega K over V regime we have been able to probe, with no found exceptions. Its license is effectively universal, within the limits of human observation. It is provisional because we can never test all possible windows. Relativity and quantum field theory are in this category. They are not proven true in a philosophical sense. They hold a provisional universal license because they have survived every stringent test across extreme variations for over a century. Notice universal is in quotes. Episode 11 forbids the final metaphysical label of universal truth. We only grant licenses based on survival portfolio. A provisional license is the highest we can award. Now, we must state the mandatory episode 11 axioms, now seen as the engine of this empirical ladder. Rules do not become real by elegance, consensus, or tradition. They earn a license only by surviving falsification, variation, independence, and scope discipline. The empirical constraint process is the enactment of this axiom. Surviving falsification means not being invalidated by a contradictory sentence. Variation is the deliberate testing across omega, k, v regimes. Independence is confirmed when different labs with different pipelines find the same survival. Scope discipline is the honest maintenance of the license boundaries. And when a rule fails, we do not believe harder. We tighten, downgrade, or retire its license. The maturity ladder is the institutionalization of this principle. Failure within scope leads to tightening, narrowing the scope. Failure at the core leads to downgrade, back to candidate, or retirement. The skill you gain from this part is portfolio assessment. You learn to evaluate any scientific rule not by its fame or textbook status, but by its survival portfolio. What is the range of omega, k, and v over which it has been tested? How independent are the verifications? Has its ledger, energy tallies, etc., remained stable, or does it require patches? This skill allows you to gauge the real strength of a scientific claim and its appropriate domain of application. This has direct bearing on contemporary physics debates. Is string theory an empirical constraint? Currently, it lacks a survival portfolio across any licensed window of observation. It is a candidate with a huge body of elegant mathematics, but it has not yet passed through the empirical constraint filter. It remains in the realm of logical and ontological exploration. The firewall, as described, explains why it is not treated as an established law. Finally, let's summarize the epistemic function of this part. We have defined empirical constraints as the firewall process that elevates a pattern to a rule based on its repeatable survival across varied windows. The audio equation is, for I from 1 to n, gi phi is satisfied within delta. Survival must be tested across omega regimes, k regimes, and v regimes, the full triunity. Real rules stabilize the energy tally. Spurious ones cause context-dependent wobble. The explicit prediction is generalization within the validated scope. The explicit falsification is breakdown within a previously validated scope, leading to license downgrade or narrowing. The license consequence is progression along a maturity ladder. Candidate, scoped, provisional. This strengthens the firewall by providing the final objective criterion for rule certification. It replaces authority with audit and dogma with a documented survival portfolio. It ensures that the laws we rely on are not merely stories that fit the past, but robust patterns that have endured the storm of deliberate, varied testing. If you want to see the full mathematical derivations and exact equations behind this idea, you can search for Holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. Carry the discipline of the survival portfolio with you. When you hear a claim of a law of nature or a scientific fact, ask for its portfolio. Over what omega, k, and v has it survived? What is its license? This is the mark of a mature scientific mind. Now we bridge to a final subtle filter. We have rules that survive empirical tests. But could it be that the rules we discover are partly shaped by the language we use to describe phi? Next, how do we separate what's real from what's merely our chosen dialect? Salam, and peace be upon you.